This is Chapter 6, Problem Number 8, Elasticity. It covers the T-shirt problem in our textbook. It's quite an interesting problem. It has a lot of little things going on in it. And so here's the, I reproduced the table that's in the text. And so let's look at it. We have price, and we're looking at the price of T-shirts, and we're looking at a $4, $5, $6, and $7 price, and we're looking at quantity demanded for the average tourist with $20,000 in income. And so here's the thousands of demand, and then we also have quantity demanded when the average tourist has $30,000 worth of income. And so the question asks, using the midpoint method, calculate the price of elasticity of demand when the price of T-shirts rises from $5 to $6 and the average tourist income is $20,000. Also do the same thing when for a tourist of 30,000. So let me do the calculations here. Get this out of the way. Part A, midpoint for elasticity of price demand at $20,000. So we do that calculation. So it's telling us the price goes from $5 to $6. $5 to $6 is a dollar increase. It's positive. Divided by the average of those two, which is $5.5. And then when we look at the table, we see quantity changing from 2,400 to 16. So we end up with 1,600 minus the 24, so quantity dropped by 800, and the average here was 2,000. Okay, the average of for the midpoint. This turns out to be 0.40 to 0.1818, and so what you see that the price increased about 18%, but the quantity demanded increased 40%. So this is elastic. And by the way, I've ignored the negative sign there. There's a negative sign here, but I've ignored it, like the textbook does throughout the chapter. So this is 2.2 elasticity. Highly elastic. Okay. Now, at $30,000 average income, the elasticity of demand, okay, well, for a $5 to $6 change is again, it's the same price effect, the same price changes here, which turns out to be the 18%. Okay, but now we go from 3,000, or we go from 42 to 3,000 with a midpoint of 3,600 for a 0.333% change, a 33% change. So let's look at this again. Price went up 18%. Quantity fell by 33%. So that means elasticity is 1.83. It's again highly elastic. So what do we conclude from this? And that's what's missing from the problem. What this asks is basically to calculate it. But so what do you conclude from this? Well, higher income people in this case are less sensitive or less responsive to price changes. A better way, I think, to interpret this is, as your income falls, you're more responsive to an increase in price. I think that makes a little more intuitive sense. When you're relatively lower income and you get faced with a price increase, you're more likely to react strongly to it than somebody who's has a higher income. Now let's turn to Part B. Part B says, using the midpoint method, calculate the income elasticity of demand when the price of T-shirts is $4 and the average tourist income increases from $20,000 to $30,000. Also calculate it when the price is at $7. Okay. So B, at a price of $4, we're going to have income elasticity. And it tells us we're going from, we're looking at tourist income going, average tourist income going from 20 to 30,000. I'll chop off the zeros. Okay. So that's the bottom of the fraction. So remember, it's the change in, it's how income changes quantity demanded in this case. And so the bottom of the fraction is the percentage change in income, which is 0.4. 40%. We have a 40% increase in income from 20 to 30,000. And then the quantity demanded went from 3 to 5. So 5,000 minus 3,000 divided by the midpoint of 4,000 gives us a 50% increase in quantity demanded. So your income goes up by 40%, quantity demanded goes up 50%. That's elastic. That's greater than 1, so it is elastic. Now let's look at $7 and try to interpret from there. Now at $7, again, we have the same denominator of a 40% increase in income, but we go from 800 to 1,800 in the quantity of T-shirts. That is a 77% gain, and that is a 1.92% income elasticity estimate. So what do you interpret from this? What do you see from these two numbers here? Well, you see that as price rises, income elasticity rises. So how do we interpret this? Well, it's a little harder. Let me summarize it again. It's a little harder to interpret. We had at $4 an income elasticity moving from 20 to 30,000 at 1.25, and then at $7 we had an income elasticity at 1.92. So as you can see, at higher prices, income elasticity is higher. I just said that, but I'm looking for a more intuitive explanation. And what you could say is that, look, when prices are high, demand is sensitive to changes in income. So when prices are high, quantity demanded is more sensitive to changes in income. While that explanation is an improvement on our previous explanation on this, I'm still looking for something more intuitive. And I think the way to go about that in this case is to ask, is this item, in other words, T-shirts sold at Crystal Lake for tourists, is this item a luxury good? And the answer is yes. And remember what a luxury good is. When, well, let's back up 1 second. When you have income elasticity greater than 0, that implies it's a normal good. In other words, as income goes up, you consume more. When income elasticity is greater than 1, it implies a luxury good, and we certainly have income elasticity higher. In fact, what you can see is at higher prices, it seems even more like a luxury good, which is quite interesting. At high prices, it's even more responsive. So income in this case, remember, income went up 40% in both cases. Income went up 40%. And we had a substantial increase in demand. when we changed income. So it does appear to be a luxury item that becomes more sensitive, I guess more luxurious as the price rises. I mean, think about it. This is, as the problem is structured, it's tourists, it's people on vacation at some place called Crystal Lake. And so it kind of all fits together when you ask that question, is it a luxury good? And it is. And under normal circumstances, by the way, you would think T-shirts would be, well, you'd probably think that they were a normal good, and maybe if you were wearing them to work, it would almost be an inferior good. Remember, if the income elasticity is less than 0, then it's an inferior good. And so you think about T-shirts, you know, that you could almost think of them as possibly being inferior in some cases, depending on the context, a normal good. But here the context is different. Let's take the problem one step further and ask ourselves, look, if all this data came from one particular store, is the store better off in terms of revenue? Is it better off having a high price or a low price? And well, I'll answer the question looking at the $20,000 average tourist, and then the same results basically come out if you look at the $30,000 average income for the tourists. So we're asking ourselves revenue. So here at 20,000 income mark here, at $7, the demand was 800 units, 800 T-shirts, for a total revenue of $56. At $4, the demand was 3,000 units for $12,000 in total revenue. It looks like if you a lower price brings in a lot of people, and that's what the elasticities are telling us. Price elasticity is the demand, and so if we solely want to focus in on maximizing or increasing total revenue, this would be the place, a lower price. We can graph this like we did in class. Let's see if I can put it here. Price, here's a demand curve, quantity, quantity, here's total revenue, looks something like this. You know, at this point your unit elastic. We're up in this end because our price elasticity numbers were for demand were 2.2 and 1.8, and so at $7, right, we come down, and here's our total revenue. Our total revenue would be, in this case, 56. And then if we drop price to 4, our total revenue would be higher. Come up over to here, it's $12,000. And so we don't have enough data to be able to answer where is the optimal point. Where are we at unit elasticity? But we are on this left side, and so this is telling us decrease price, increase quantity, move in this direction, you're going to increase total revenue. So from a managerial economics perspective, technically not this course, but still valuable for an MBA's perspective. The next problem is in Chapter 7 on taxes. It's problem number 2, and it has to do with imported trucks and taxes, excise taxes on imported trucks. Let me read the problem. The U.S. government would like to help the American auto industry compete against foreign automakers that sell trucks in the U.S. It can do this by imposing an excise tax on each foreign truck sold in the United States. The hypothetical pre-tax demand and supply schedules for imported trucks are given in the accompanying table. So here it is. Here we have price, 32,031, and so on down here. I took the zeros out, and the same thing with the quantity demanded and quantity supplied at each and every price. So that's the information that's given. And the first question, like we always ask, so we make sure we're all starting in the same place, is In the absence of government interference, where's the equilibrium price? Where's the equilibrium price to start out? The equilibrium before the tax shows up right here, okay, where we have supply equals demand at a price of 30,000. So that's where we're starting out. Okay, and then it says, question B says, assume the government imposes an excise tax of $3,000 per imported truck. Illustrate the effect. Okay, and let's see. Illustrate. So before we actually get into the graph, although graphing this would lead you to the solution, you could figure it out from the table. So basically what we need to do is we need to form a wedge of $3,000. So we need a difference here. We need a difference along here of $3,000 in price. And when we have that difference, we need supply and demand to equal. And so we could go 32 versus 29, right? And so coming down, 32 to 29, that's a $3,000 gap. And look, supply equals demand, but you would be wrong if you picked that as the appropriate place, because when you impose a tax, your quantity doesn't go up. Like, it doesn't go up, it should go down. So we know that this isn't the solution for the wedge. So go to 31 to 28 as a $3,000 gap. And when we do that, we say, oh, you know, look, 200 to 200. It's less than the 300 where we started with. So we impose a tax, it's going to reduce the output. And so we have $3,000 gap, supply equals demand. And you could go down here to make sure there's no other places where you have supply equals demand at $3,000. So the next one would be 30 to 27, but there's no place where the supply equals demand at 30 and 27. So let's graph this relationship. Keeping in mind this is the price of imported trucks. This is the quantity of imports. You have if you notice carefully, you'd have to plot this out on graph paper, but the demand curve is relatively flat, meaning that it's pretty elastic. And why is it fairly elastic? Because there's a lot of substitutes for imported trucks. The demand curve, the supply curve, is a bit more steeper. So I'm going to try to draw the supply curve here, a bit more steeper, and you can view that as, you know, it doesn't really tell us the time frame, and the time frame is certainly important when you're looking at supply elasticity. But basically, it's not as elastic as the demand. So it's a steeper line, and it would have to do with, you know, the ability of the foreign automakers to adjust and shift their output in response to changing prices. And that's a little harder. I mean, it's hard to change output of a large company producing autos. So having a steep demand curve, a supply curve, and a flat demand curve kind of makes sense, is what I'm saying. So here we have 300,000. Here we have a $30,000 import price according to our table. So that's where we start off with equilibrium, and the $3,000 wedge that's going to be put in here basically shows up here. So this is the 31 and this is the 28. So consumers are going to be charged 31,000. The producers of foreign trucks will be receiving 28,000. This square here, well, rectangle, I guess, this rectangle represents the total revenue to the government for imposing the tax. So what is it? It's $3,000 times the quantity. So the quantity here, remember, is 200,000. So 200,000. This is a total of $600 million is tax revenue. And the tax revenue comes from, it's coming out of consumers right here. This component right here, this little wedge, not a wedge, but this thin slice here, is consumer surplus that's being transferred in turn to the government, which in turn gets somewhere transferred back to society somehow. And here's producer surplus that's lost to the government, and then the government again takes that revenue and sends it back to society somehow, some way. The triangle here is the deadweight loss. The deadweight loss, as we look here, most of the deadweight loss comes from the foreign producers. Most of the loss to society comes from the foreign producers, which is exactly what the tax was intended to do. It was intended to restrict imports. It did, right? Reduced it by 100,000 units, but it raised price. So it took a bite out of consumers who want to buy imported trucks, but it took a bigger bite out of the producers. And so again, this is deadweight loss because transactions that would have happened under normal circumstances, meaning a normal unrestricted equilibrium, we'd be here. And so by restricting output, we lost all these transactions and the producer and consumer surplus associated with it. That's completely gone. I should say, I should be careful here. It's completely gone in this graph, and I'll tell you why in a little bit. There's other things going on. In isolation, this is deadweight loss for sure. I mean, this is when you're just looking at imported trucks on this graph, there is a deadweight loss in those terms. So now what I want to get to is the impact on the domestic market. And so here we have the price of domestic. Here we have the quantity of domestic cars, domestic trucks. So we could have a demand curve, we could have a supply curve. Here's equilibrium before any excise tax on foreign produced trucks comes into play. But as soon as that tax comes into play from the previous part of the problem, what happens is demand for domestic cars go up. Demand for domestic cars goes up, and so does the price. And why is that? Because remember from chapter 2 that demand curves shift in response to changes in the price of related goods and services. For domestic trucks and foreign trucks, they're substitutes for each other. So if foreign trucks become more expensive, people steer away from foreign trucks, go into domestic trucks, the demand increases. We move up here to a new equilibrium. And so what's happened is, in the domestic market for trucks, we had this producer surplus, we had this consumer surplus, and now what's happening? We have a loss of consumer surplus of this area. It now gets transferred to producer surplus. This area right here, this area right here, this area was consumer surplus. Now is transferred into producer surplus, which means domestic automakers are doing quite well on this. Domestic automakers are also gaining in this area. Okay? This was uncharted territory before. And now, so producers are also gaining this part of the market, and so there's a gain. So quantity has gone up. We don't really have the information in the problem to talk about that specifically, but quantity has gone up. Price has gone up for the domestic automakers. So really, consumers ultimately are paying for this tax. Now, hopefully, if the government's efficient, it can send back some of this revenue back into society. But so remember, when I was talking about this being deadweight loss in the imported market, this was deadweight loss, and in a sense, just in this market, that is deadweight loss. But you look at the gains here; it's offset by some gains in the fact that we have more business operating in some respects. There's actually more activity going on, and so more people are benefiting to some degree. Now you also have to keep in mind what's actually going on in this part of the graph? Well, this part of the graph, what it's doing is we're in a domestic market. It's propping up domestic automakers that may be inefficient. So in a free trade situation where there's no excise taxes on imports, we'd be right here. What this says is automakers are willing to produce, domestic automakers are willing to produce at these prices. And if they're inefficient and their costs are too high, which means they're in this area, there's no transactions, there's no business taking place because their prices are too high relative to what consumers are demanding. But when you impose that tax, what it's doing is you're propping up what was previously inefficient companies that couldn't produce trucks at a price that consumers demanded them. And so you're increasing the quantity, and that quantity is not necessarily a good thing. So there are some benefits here without a doubt, but there are some costs to it also. The point is, like I've been telling you all along in Chapter 7, taxes distort, and there's lots of ways that these distortions take place, and this is just one example. Domestic prices go up, consumers get hurt, and it props up domestic automakers and domestic producers that were not necessarily efficient to begin with.